All right, G. Is this screen visible to you?
Yes, sir.
Okay. We have a second lecture of week number 6 today, which is again about forward kinematics, and we would be solving some more problems in order to reinforce whatever we have learned until now, and this would culminate our uh, lectures about the forward kinematics in this week, and from the next week inshallah we will start our inverse kinematics problems about in robotics. So this is a problem solving session. We had uh, solved two problems in the previous lectures, and we also looked at the uh, looked at the transformation matrices of two industrial robots, which were Puma 350 and ML3. So these are the two industrial robots about which we had studied, and we have also done two problems to reinforce our learning curve. So today, um, what I'm going to do today is to uh, solve some more problems in order to know that in order to give practice to you all so that we can uh, reinforce whatever we have learned until now. So this is the problem which is given in the exercise book, which is number 3.4. And what does it say? Let me read it out for you. The arm with 3 degrees of freedom shown in figure 3-30. This is the figure 3-30 which is drawn underneath. It has joints 1 and 2 perpendicular and joints 2 and 3 parallel. So we have joint 1 and joint 2 which are perpendicular to each other. So in fact, if I just look at this, so this is the rotation of joint number 3, joint number 1, which is the station. So if I say this as joint number 1, and this is actually frame number 1 here, so this is shown here. So this is the rotation of joint number 1 is shown here, and this is joint number 2, which has a rotation of theta 2. So these two are perpendicular to each other as written here, that it has joints 1 and 2 perpendicular and joint 2 and 3 are parallel. So this is joint number 2, which is shown here. So this is theta 2 and this is theta 3. So in fact there is another um, joint here which is rotating with theta 3, and these two are parallel. So here we have a third frame somewhere here. This is the third frame, and this is the tool frame which is shown here. So we are shown the base frame and the tool frame here, and this is the side view. This is the side view which gives us the rotational joint here, L1, L2, then L3 and L4. So these are the link lengths given to us. So as pictured, let us now read it again. So starting from here, the arm with 3 degrees of freedom shown in figure has joints 1 and 2 perpendicular and joints 2 and 3 parallel. So as pictured, all joints are at their zero location. Note that the positive sense of the angle is indicated, and it is indicated with the help of the rotation of theta 1, theta at 1, 2 and 3. So this is the positive sense of rotation of the joint angle. So what we need to do is that we have to assign link frame 0 to 3 for this arm. So we have to assign the links, then that is on the sketch of the arm showing the attachment of the frame, and then derive the transformation matrices 1 with respect to 0, 2 respect to 1 and 3 with respect to 2. So these are the frame. So let me just go to the next slide, to the next. So here we have assigned the frame. So let me just show you here. So this is the frame 0. This is the frame 0. This is frame 1. These are the assignments now which are done. This is frame number 2. We have frame number 3 here, and we have the tool frame here. So these are the assignments of the link of the frames to the links. जी, तो यहाँ तक कोई ऐसा इशू आपको नजर तो नहीं आ रहा, बिल्कुल स्ट्रेट फॉरवर्ड है. सो हमने जीरो फ्रेम जो है इनफैक्ट उसको हमने एस फ्रेम, जिसको यहाँ हमने ये वाला फ्रेम एस फ्रेम था, वी हैव गिवन दिस एज shown this as zero frame here, and we have shown the tool frame as frame number 4. So we can write down here that this is frame number 4. Alright, so we have now 4 frames attached, and then we can just write it down. So since we have the tool frame here, which is we may add this tool frame into our DH table, and if we do not add this, so this will not make any difference. Reason being that we are only interested in the joint parameters. So this link length, which is given by L4, will not come into action, because we would only be interested in transformation from 0 to 1, then transformation from 1 to 2, 2 to 1, sorry, 1 to 0 transformation, then 2 to 1 transformation, and 3 to 2 transformation. So let me just write down these parameters. So let us see, and we say this is joint number 1, joint number 2, and joint number 3. So by looking at these frames and their orientation, so we can see that joint 0, that frame number 0 and frame number 1, there is a difference between, there is an offset and a link, or not offset, the link length involved between these two is L2, L1 minus L2. And what is the alpha angle between them? So since both the Z's are aligned, so the alpha angle is 0. However, there is an offset. Offset between these two is also 0, but there is the link length is 0, because why it is called 0? Because these can be coincident with each other, but there is a difference of offset between x0 and x1 that can be given by L1 plus L2, and these can rotate with respect to each other by an angle theta 1. Now, by looking at 2, which is between 2 and 1, so that Z has an angle between them which is 90 degrees. Then these are coincident, so there is no link length involved, there is no offset involved. However, there is a movement and there is a rotation involved between these two. And then if we look at the joint 3 and 2, so there is an offset involved between these two, which is the alpha angle, because Z both are parallel to each other, so there is no link twist involved. There is an offset, there is a link length involved, which is L3, There is no offset in between, and there is an angle rotation, which is theta 3. So this is how we can make the DH table, which includes our link and joint variables. So if I go on to the next slide, so let me just see that what do we have here. So let me just write down these here again. So we had um, 1, 2 and 3, and we had 0, 90 and 0. We had 0, 0 and L3. We had an offset of L1 plus L2 here. Then we had 0, 0. We had theta 1, theta 2 and theta 3. So this is the parameters. These are the link parameters which we came across. So now what do we need to do is that you know that this is the criteria. This is the criteria to write down the transformation matrix between any two joints. So let me see. So this is actually, this is going to give me T1 to 0, T1 to 0. This is going to give me T2 to 1, T2 to 1. And this is going to give me T3 to 2, 3 to 2. So if I write these things down here, so T0 to 1 is going to be cos theta 1 minus sine theta 1, 0, 0. So what I am doing here is that I am taking this, I am repeating this time and again just to give you a reinforcement that I am considering this. I am putting the values here, and in turn I am getting, in turn after putting the value here, I am getting this here. Alright, so let me just now complete it, and this will be cos theta 1 minus sin theta 1, 0, 0, then sin theta 1 cos theta 1, again my 0, 0, 0 and 0, then sin theta, then 0, 0, 1, and now there is going to be an offset in between, which is actually in z direction. We can see here that this is the offset which is in z direction. So we will have L1 plus L2 here, and then we will have 0, 0, 0 and 1. So this is the first transformation matrix which we were required to find out. Now the second one was T2 to 1, and this can be given by, this can be given by this row, and we can write it like this. This is cos theta 2, this is cos theta 2 minus sin theta 2, 0, 0, 0, 0, then 0, 0, 0, 0, minus 1, 0, then sin theta 2 cos theta 2, 0 and 0, finally 0, 0, 0 and 1. So this is the second transformation matrix, and the third transformation matrix, which is between 3 and 2, will be given by this row, and it can be written as cos theta 3 minus sin theta 3. Let me just shift it a little like this. So cos theta 3 minus sin theta 3, then 0, 0, and now the L3, you know that this was L3 between 2 and 3, and it is in the x direction, so we will have L3 here, then S3 cos sin theta 3 cos theta 3, 0, 0, then 0, 0, 1, 0, 0, 1 and 0, and finally 0, 0, 0 and 1. So these are the three matrices which we were required to find out. And now if you want, then you can know the full transformation, which can be given by the equation T 0 to 1, t, um, sorry, let me just correct it. So we can have t3 with respect to 0, and this can be given by t 1 to 0. I'm sorry, मैंने यहाँ पे गलती की है, and you did not point out this. This is actually t1 to 0. This is t1 to 0. So t1 to 0, then t2 to 1, and t3 to 2. So just a reinforcement that these should cancel out each other. Just this is, we are confirming that whether we have made the right equation or not, and the 0 comes here and the 3 comes here. So now multiplying all these three transformation matrices, you can find out the transformation matrix of link number 3 or frame number 3 to 0. So this was just to give you a reinforcement of what we have already studied. G, should we move forward? मेरा ख्याल में ये चीज़ें अब आपके knowledge में आती जा रही हैं आहिस्ता आहिस्ता, and I hope that you people are practicing at home as well, because the practice will make you perfect to calculate all this. So let us find out another, let us talk about another problem, which is problem number 3.8, and this is also given, taken from your book. So the figure given, which is 3.31, it is given the location of the tool. So we have the tool frame here, we have the tool frame here. So the location of the tool, which is given by T transformation of T and W. So the location of tool T is given with respect to wrist, and this is given by this transformation. But this is not accurately known. So using force control, the robot feels around with the tool tip until it inserts into the socket or goal at location, which is given by a transformation GS. This is G, this is frame G, and this is station frame. So I remember, and you also, I think you remember, that this is what we studied yesterday, in which we defined certain frames which included the base frame, the wrist frame, the tool frame, the station frame, and the goal frame. So since we do not know this accurately, but we know this T G to S, it means T G to S. So if I draw, this is transformation G to S. So this is known to us. So now what happens? Once this calibration, a configuration in which G and T are coincident. So what do? That we actually insert this tool frame into this slot, which is G. So the tool frame and the goal frame, they become coincident. Okay. So at this position, the position of the robot now, transformation wrist and base. So transformation between wrist and base. So this is actually the transformation of wrist with respect to base, is figured out by reading the joint angle sensors and computing the kinematics. Now, what is the assumption? The assumption is that transformation of station with respect to base, so transformation of station with respect to base and transformation of goal with respect to station, this one. So these both are known. Now we need to find out the transformation equation to compute the unknown tool frame, which is T transformation of tool with respect to wrist. So let me just draw it here. So this is something which we want to find out, which is transformation of tool with respect to wrist. So this is what we want to find out, and when we will be able to find it out, when T and G, T and G, they will be coincident with each other. So the tool frame T is going to be coincident with tool frame goal with tool frame G. So at that particular time, we will be able to find out that what is the transformation between tool and wrist. And what all we know already is, we know that I have marked them with a tick. We know these two transformations. I'm now marking them with a green tick. So we know these two. So let us now solve this. So what was the first condition? The first condition was that frame G is coincident with frame T. So this is the first thing. Now, let me just write it down. So what do we, with respect to G, with respect to G, what do we, let me just write it down so that will give you an idea that if we are moving from base to wrist, so if we are moving from base, if we are moving from base to wrist, okay, we are moving from base through wrist to tool. So we are moving from base to wrist and to tool. So let me just write it down, write down this equation. So this will be tool, the transformation wrist to base and transformation tool to wrist. So this has to be equal to what? Equal to these are coincident. We have taken a condition in which the tool frame T and the tool frame G, they are coincident. They are aligning with each other. So it means that if we move from base to wrist to tool, so we are at the same place, and similarly, if we move from base to station and to goal, so this will again be at the same position. So this is our second, let me just take this color. So the second transformation is from base to station and from station to goal. So if I write it down here, so this will come out to be the transformation which is from station to base and the transformation which is from goal to station. So what we are interested to find out is this. So what we do need to do is to take this onto the other side. So let us see what happens here. So we would be able to come out with a solution of a transformation which is between T to W, and this is going to be, when it comes onto this side, so this becomes T inverse of wrist with respect to base, then transformation of S with respect to base and the transformation of goal with respect to station. So this is the equation which we get And we know what? The inverse of this is actually going to give me, the inverse of this is actually going to give me the transformation of transformation of base with respect to W. Then I'm going to put it as it is here, this one, and I'm going to put as it is GS here, and this is going to be equal to transformation of tool with respect to wrist. So now let's see if we have made it correctly. Okay, so S cancels with S, the B cancels with B, B cancels with B, and what mistake I have done? No, I have not done any mistake. In fact, this is equal to T, so this G is equal to T. So it means that we have now brought W here, and this G comes here, and we know why that G is equal to T. So there is no mistake I have made. So G is equal to T. We started off with this condition. जी, इसके ऊपर कोई कमेंट?
No, sir.
जी, समझ आ गई ये वाली बात? So quickly we are going to
जी
solve
सर.
two more questions. जी, quickly we are going to solve two more questions just to give you an idea. So let me just move forward, and I'm now going to solve this question for you, which is let me just take this. Okay, so which is the figure 3.3. So this is the figure 3.3 shown, which gives you a schematic of wrist, which has three intersecting axes. So these all axes are intersecting here at this point. But all these, we have studied the wrist in which all the three joints are at right angle to each other. But in this particular case, the one of the axes is not at right angle to the other two. So these are not the orthogonal axes. So let me just assign the frames to all these. So let me just assign the frames. So if this is the Z4, मैं इसको 4 इसलिए डिफाइन कर रहा हूँ कि यहाँ पे थीटा 4 गिवन है, और this is Z4 and this is Y1, and X would be going into the board. So Z and say and X would be going into the board. So let me just assign a frame here also like this, which is Z5, and we will have again a Y5 here. This is actually Y4, and again if I curl my finger from Z to Y, so X would be going into the board, and then we have the third like this, which is Z6, and its Y would be like this. So अगर मैं इसको इस तरह से बनाऊं, and then definitely I need to assign a frame 0 also. So let me just assign a frame 0 here also, which is coincident with 4. ठीक हो गया जी? So अब I can write down, अच्छा, then I can bring all of them here. ये आपको पता है कि I can bring all these here because they are intersecting axes. So let us see, इसका मतलब क्या हुआ कि there is no offset in between. ठीक है? Since all of them will be coincident with each other, so there is not going to be any offset in between. So now let me just write down the okay. So what we are interested to find out is alpha I minus 1, then AI minus 1, then BI, and theta I. So what we have here with us is the link joint number 4, 5, and 6. So between 4 and 0, everything is 0 except for theta 4. Then between 2 and 3, between, 5 and 4. So between 5 and 4, so there is an angle between the z's, which is given by alpha, which is given by phi. So there is a link twist between 5 and 4. There is no link length involved. There is no offset involved. However, there is a rotation involved in between these two. Now 5 and 6, between 5 and 6, again there is a link twist involved, which is given by the angle minus phi here. ये हम वही वाली कन्वेंशन फॉलो कर रहे हैं, आपको याद होगा, जिसके अंदर हम अल्फा आई, ए आई, देन डी आई और थीटा आई फाइंड आउट करते थे. सो वो कन्वेंशन अपने सामने रखें और इसको, ये जो मैं लिख रहा हूँ, इसको वहाँ पे सॉल्व करें तो यू आर गोइंग टू कम अप विद दिस. सो वी आर गोइंग टू हैव minus phi, then there is no link length, no offset, but there is a theta involved in it. So let me just draw these like this so that we can see that this is a DH table. Okay. So this is the DH table which can be found out, and these are actually the link parameters of this wrist, in which one of the joint is at an angle phi. Now you can make the transformation matrix of 4 to 0, then 5 to 4 and 6 to 5. वो आप अपने आप के ऊपर इसको प्रैक्टिस करके बना सकते हैं. So these are the DH parameters which I have shown. Let me give you one more example so that there is some more reinforcement for you. So this is another link which is RPR. So we have a revolute joint here. So we have a revolute joint here. We have a prismatic joint here, and we have a revolute joint here. So let us first assign the frames to this. So since it is rotating at an angle theta, so Z1 would be coming out. So let me just make the X1 here, X1 here, and Y1 here, and the Z is coming out. And since this is the frame number 1, so I have assigned this frame at joint number 1. This is a prismatic joint, and it will be moving in this direction, either in this direction or in this direction. So I assume that it is moving in this direction. So I take this as Z2, and correspondingly we will have X2 in this direction. And this is a prismatic joint, please remember this. And then we have a third joint, which is a revolute joint, which is joint number 3. And since the Z would be coming out, the Z would be, its direction of rotation is like this, theta 3. So Z would be going into the board in this case. So Z would be going into the board, and we will have X3 here. And since X and Y has to give us Y, X and Y has to give us Z, and Z is going into the board. So we will have Y3 here. Okay. So what happens if at all we give a wrong rotation here? So what happens that in the DH table we will have a negative sign. If we give a wrong notation here, so we will have a negative sign in the DH table. So that will actually give you an idea, okay, what happens if we give a wrong notation here. Actually, now since there is a movement involved in this P, so actually this is going to be a link length involved between these two, which is given by this is not the link length, this is actually the offset involved between these two. And this will be given by, let me just give it L2, and there is an offset between these two also, so this can be given by L1. Achha. ये जो एक प्रिज्मेटिक जॉइंट होता है, इसको आपने जहन में रखना है कि जब भी जहां प्रिज्मेटिक जॉइंट इन्वॉल्व होगा, देयर विल ऑलवेज बी एन ऑफसेट. There will always be a d involved in it, but there will not be any theta involved in it. तो ये जहन में रखना है कि इसके अंदर आपका जो थीटा है वो इन्वॉल्व नहीं होगा. Okay, so let us now see the dh parameters. Let me just draw it for you. So what we are interested in, we are interested in finding out alpha I minus 1, ai minus 1, di and theta I. So what joints we have here? We have 1, 2 and 3. So what is now between 0 and 1? So these are coincident, so there is no link twist, there is no link length, there is no offset. However, there is a rotation involved. Okay. Now number 2, between between 1 and 2. So let's see, the z, both the z's have an angle between them is 90. So there is a link twist which is given by 90 degrees. Then there is a link length involved which is given by L1. And since this z2 would be, this x2 would be moving, so there is going to be a shift which is called an offset, which is given by d1 here. And since it's a prismatic joint, so there is no involvement of rotation. Now coming on to 3. So 3 is a rotational joint. So the angle between z3 and z2 is given by minus 90 degrees. There is no link length involved. But there is an offset involved between these z's, which is given by L2, and there is a rotation between theta 3. ठीक हो गया जी. सो ये अब आपने, और ये जो हमने बनाया है, ये वही हम 4 जो कन्वेंशंस फॉलो करते हैं, ये उन्हीं कन्वेंशन को देख के हमने ये बनाया. सो व्हाट आई वुड रिक्वेस्ट यू टू प्लीज गो बैक होम and look at those 4 conventions which we had discussed earlier, and keep those conventions in front of you, and then make these tables again, and then try making these parameter tables by shifting the alignment or by shifting the frame assignment. So you would come with a number of other DH tables also. ठीक है जी. सो एनीथिंग एल्स, यहां तक कोई क्वेश्चन? Okay, so if there is no question, so I would request you to please practice these at your home again, and then there are certain more questions given in your book, so try those questions also. So this will give you a practice. On this weekend I am going to upload another assignment for you which is based on MATLAB, and that will actually be revolving around writing down a code for the forward kinematics of a manipulator. So I'm going to put in the narrative for this also. So but I'm going to do it on the weekend. So just to remind you that your first assignment is due on Saturday midnight. So all those who have not started off yet, I will request them to please start working on the previous assignment, which is assignment number 1, and that is due to be submitted on the coming weekend on Saturday and not on Sunday. So please remember that, don't get carried away with the idea that it is on the weekend, so it is going to be submitted on Sunday. So sir, please remember that it is to be submitted on Saturday. So if there is no question, so I can just call off this meeting, and if you have any questions, so I am available. Let me just mark your attendance. Let me first stop the recording.